Hi students, now I am going to teach 4 marks questions from first year chemistry. 12th question now I am explaining. This is the question. Derive the relation between Kp and Kc for the equilibrium reaction. What are Kp, Kc? Kp is the equilibrium constant with respect to pressure, equilibrium constant with respect to concentration. Now let us take one hypothetical example. From that we solve the relation between Kp and Kc. This is the answer. Right. Okay. A plus B the coefficient, capital B is the reactant name, just B. This is the symbol for equilibrium. C is the coefficient of product C plus D is the coefficient of product capital D. This is the reaction. From this we can bring the relation between Kp and Kc. First we will write the Kc, equilibrium constant with respect to concentration. Kc equal to, what is the formula for equilibrium constant? Simply product concentration by reactant concentration. The product of product concentrations. What are the products? C and D. C is the product. If you close with square brackets, it is the concentration of C. The C is the name of the product. If you write these square brackets, then it is the concentration of that product C, and its power C. Whatever coefficient is there, that we have to write in the power of that C, and into D is the product name. If you write square brackets, it is the concentration of D, and what is the power here? What is the coefficient? Coefficient is D, so you have to write that in power. So these are the two products. C and D are the two products. Here product of products concentration. Product means multiplication, another product means yield from this reaction. So product of product concentration with product concentration with their powers by, and the same you have to write like this only for reactants. This is the A concentration with power A and B concentration with power small b. This is the equilibrium constant with respect to concentration. Okay. Now we write Kp, equilibrium constant with respect to pressure. Kp equal to pressure of A with power A, and the pressure we have to write pressures only here, all reactant A pressure, reactant B pressure, like that we have to write. First we have to write products now. So first pressures of product we have to write here, concentrations of pressures of products. That means pressure of C with power C, this is the coefficient, into pressure of product D with power small d. This is the coefficient by same pressure of A with power small a, pressure of B with power small b. This is the equilibrium constant with respect to pressure. Equilibrium constant with respect to concentration. Square brackets indicates the concentration, P indicates the pressure. Okay, that's now we know one formula for gaseous molecules for ideal gases. PV equal to nRT. This is the ideal gas equation. From this we can write pressure P equal to, if this V goes this side, N by V RT. What is N by V? Number of N means number of moles, V is volume. Number of moles per particular volume is called concentration simply. What is concentration? Number of moles. Number of moles means number of molecules simply. So number of moles in particular concentration, particular volume is called concentration. So P equal to this term we can write CRT, where C is the concentration, that is equal to N by V. Okay, here P is the pressure of gas, R is the universal gas constant, T is the temperature. Now we substitute these pressure values in this equation. Now Kp equal to pressure of C, that means C okay. First we write here these values. What is this? Is the P equal to CRT na? Like that we have to write for PC. PC power C equal to, what is PC? Concentration of C and RT whole power C. This is the we have to write like that. P D power small d equal to concentration D RT whole power small d, and P pressure of A reactant with power small a equal to concentration. This is the concentration term na? So this is the pressure of reactant A. So here we have to write concentration of A. So that I am writing like this, RT with power A. Like that PB equal to B concentration RT. Okay na? This we have to write carefully. Okay na? All these values here I have written. So you have to write all these with carefully. Okay, once again I am telling, this is the already we got formula P equal to CRT. C means concentration, this is the universal gas constant, this is the temperature. Now we want to these values. Pressure of reactant C with power C. So pressure of reactant C means here we have to write C concentration. Formula this na. So C concentration means this is the reactant C with the square brackets. This means C concentration, and RT and power, this is C na, power, it has the power C. So I have written that C here. Okay, like that. This is the reactant D pressure with power D. So reactant D concentration, if you write square brackets for D, this is the concentration of the D reactant. Okay, so concentration D and RT with power, here power is D na, so you have to write power D. Okay, like that PAPB also I have written here. Now these values substitute in this equation. Okay, now I am writing here, wait, I am writing here. Okay, so Kp equal to what is the formula? Once again I am writing this here. Equilibrium constant with respect to pressure of C with respect to C, pressure of D with respect to with power D, and pressure of A with power A, pressure of B with power B. This is the equilibrium constant with respect to pressure. Now all these values substitute in this. So Kp equal to, what is Pc? Concentration C. I am writing separately. This is the C. This C belongs to this C and RT also. So power of C and RT power of C. I separated them. Now pressure of D. This I am writing here. Okay. D with concentration power D here, and RT power D. So these only I have written here. Okay, by and PA means this I have to write concentration A with power A and RT with power A. Okay, and PB, B square brackets with power B with power B, and RT with power B. So just I substitute these values in this equilibrium constant with respect to pressure. Okay, now all these are we will be separate. All these are be separated. So C power C and D power D, and RT these right next. This is the RT power C, this is the RT power D. What is the formula? This is A power X B power A power X into A power Y. This is A power of X plus Y. Okay, that's formula. Now I will write here. Okay, RT power, this is RT, this is RT. So powers will be add C plus D by, and power A with power A and B with power B, and same like this only you have to write here. RT, here RT, here RT. So A plus B. You can write A plus B. Okay. Now you have to observe carefully. C power of C into D power of D by A power of A, B power of B. All these values equal to, you see, all these values equal to, this is equilibrium constant with respect to concentration. C power C, D power D by A power of A, B power B. All these equal to equilibrium constant with respect to concentration. That's we have to write here. So all these values is equal to K into C. Okay. Now this way, this is the RT, this is the RT. And once again another formula I am writing here. Suppose A power X by A power Y, then A power of X minus Y. That's I am writing here. Okay, RT C plus D minus A plus B. If it goes to numerator, then minus will come, A plus B. Okay, this is the next KC into RT power. All these values just simplify with these, replace with delta n, where delta n equal to C plus D minus A plus B. What is this C plus D, A plus B? These are the moles. If you take this equation, A is the mole. A moles of capital A, B moles of capital B, C moles of capital C, D moles of D. All these are the moles. So these are the CD are the product moles, AB are the reactant moles, number of moles. Okay, na? These are the product moles, these are the reactant moles. That's we have to write here. Simply delta N is the difference in number of moles. That means delta N equal to number of moles of product, right, product minus number of moles of reactant. Okay, na? C plus D means number of moles of product, A plus B means number of moles of reactant. So here Kp, this is the Kp values, na? So Kp. So finally Kp equal to Kc into RT power of delta N. This is the relation between Kp and Kc. Already this question asked for 2 marks also. So for 2 marks we have to write simply this formula and what is Kp, what is Kc, what is R, what is T, what is delta N. But 4 marks is asked derivation part. Okay, na? You see question. Derive the relation between Kp and Kc for the equilibrium reaction. Derive the relation we have to derive here. So this is the derivation part of that question. Okay, so we have to write like this finally. Once again I explain simply what you have did here. What did here? You see, this is the hypothetical equation. AB are the reactants, small ab are the number of moles of A, number of moles of B, like this. This is the number of moles of products. These C and D are the products. Small c is the number of moles of C, small d is the number of moles of capital D. First we have to write the equilibrium constant. Equilibrium constant means how we have to write product concentration by reactant concentration. Product of product concentration. That means product of means multiplication. Product concentration means C and D are the products. Concentration means square brackets with their powers. Like that, reactant concentrations. In the same way, we have to write the equilibrium constant with respect to pressure. Kp equal to, this is the pressure. We have to multiply the product of pressures of products by product of pressures of reactants. Reactants pressures, product pressures simply. This is the pressure of C product with power C. This is the pressure of D product. Pressure of D with the power small d. Like this you have to write like concentrations only. If it is concentration, you have to write the name with a square bracket. If it is pressure, just you write P and C here. Okay, after we know for ideal gas, the equation for ideal gas PV equal to nRT. P equal to, if V comes in the side, right side, then N by V into RT. This N by V, number of moles per volume, means concentration. This is C is the concentration. Okay. Now from this formula we have to write all these values. What is PC, what is PD, what is PA, what is PV. PC means, here C, in the place of C we have to write the C concentration simply, that's only. So C concentration RT, and power C is here na, so with power C, and pressure of D equal to D concentration, here C na concentration this is, so D concentration, that means square brackets and in the square brackets d, rt with power d. Like this we have to write, and these values we have to substitute in this equation, equilibrium constant. Finally we got this equation, Kp is equal to Kc into RT power delta n. So if it is asked for 4 marks, simply you write this equation 1, just I putting. If it asks for 4 marks, just you write this is the first point, second point, third point, okay na? And okay, this is the fourth point, fifth point, sixth point, and finally seventh point. Okay, if you understand in this way, like this, in this how to write the equilibrium constant is there, how to write the equilibrium constant with respect to concentration, with respect to pressure, and this formula also we learned from this. Okay, now so many things learned from this. Okay, bye.